Hello, this is perpendicular and parallel lines, proof and perpendicular lines, example 1. Example 1, they don't ask us to prove anything, but they just want to show us a two-column proof, and they want to show us a flow proof. Well, the two-column proof is really the easiest to come up with, and you're going to use that more than any other. So I'm going to look at the two-column proof, and um, you got to understand that you're going to have to come up with these things. And I think a lot of geometry students have trouble with these proofs because they think it's beyond them. They for some reason they think that this is some Einstein stuff and that they're not capable of doing this. But you just got to think, and you got to put together what you know and put together what you were recently taught in the book and come up with it. And there's always more than one way to do these proofs. I'll be showing you that throughout the course, that if you think about it, you can come up with an answer that's different from the book and different from the way anybody else does it. So anyway, you usually start with what's given. So that's all they did was write what's given there. 5 and 6 are a linear pair. So now you think about what can you come up with? If 5 and 6 are a linear pair, then they're supplementary. Okay, so if they're supplementary, they add up to 180. And so the linear pair postulate says that these pairs are going to be supplementary. And then there was this congruent supplements theorem. Two angles congruent to the same angle, two angles supplementary to the same angle are congruent. Well, I'll just show you that maybe that's not the way you have to think about it. First of all, I think that this is very straightforward to say these first two statements. 5 and 6 are going to be supplementary, 6 and 7 are going to be supplementary. And maybe you didn't think of the congruent supplements theorem. Maybe you say something like, let's see, angle 5 and angle 6 are supplementary. That means angle 5 plus angle 6 equals 180. Okay? And to be technically correct, you're going to have to put the M there. I'd probably take it any way you wrote it, because I'd know what you meant. Angle 5 plus angle 6 equals 180. And for a reason, you say, well, that's the definition of supplementary. Definition of supplementary. So now you're going to continue with that. You're going to say measure of angle 6 plus the measure of angle 7 equals 180. See, that's what it means to be supplementary, so that's the definition of supplementary. Okay, so now what? Well, now I can say that this is equal to this. See, they're both equal to 180, so I can say that this is equal to this. Or you might, so I'm going to say measure of angle 5 plus the measure of angle 6 equals the measure of angle 6 plus the measure of angle 7. So, and for a reason, you'd probably put substitution, because instead of 180 here, you're able to substitute this. You can substitute equals for equals. Another reason you could put is transitive, because two things equal to the same thing are equal to each other. That's the transitive property. Now you say, hey, I'm going to subtract angle 6 from both sides. It's a number. I'm going to subtract the measure of angle 6, and in that way I get the measure of angle 5 equal to the measure of angle 7. And that's just subtraction. And now I can say angle 5 is congruent to angle 7, and That's just the definition of congruence. See, so there's a lot of ways to come up with these proofs, and you just have to take what you know, the given, and come up with more statements, more thinking and more reasoning to come up with what you're asked to prove. If you can come up with angle 5 is congruent to angle 7, you've done it.